Thanks for joining today and welcome back to the second video in our RV electrical installation series. Today we will be covering the installation of our Victron Multiplus 3000. Now this is going to be a very detailed explanation and installation video, so if you just want a quick snapshot of the overall system, I'll link that video down below, as well as part 1, which is the lithium battery installation, and when I'm done with part 3, the solar, that will be there as well. I'd also like to thank our brand partners, Battleborn Batteries, for helping us with this awesome electrical system, as well as allowing us to live this great off-grid lifestyle that we so love. Now let's get right into the video. All right, I thought it would be good to start off with a quick overview of the wiring for the inverter. If we remove the front cover, you'll see in the upper left, there's two RJ45 communication ports. That's where you're gonna hook up your monitoring devices, such as a GX50 screen or your Servo GX, as well as the Bluetooth Smart Dongle, which is what I use. Right below that is gonna be your AC wire connections. On the left side, it's your AC in, and then it goes to your AC out, and right next to that is the AC out number 2. I don't think most people use the AC out number 2, and that basically just allows you to hardwire a certain appliance like your air conditioner or your water heater that will only run off of shore power and will not drain your battery. To the right of that, you have 2 negative battery terminals, and to the right of that, you have 2 positive battery terminals. And the reason there's 2 is because over in Europe, where these are designed, they actually use doubled up battery cable quite often, whereas here we use single larger battery cable like the 4-aught battery cable we're going to use today. I'm going to start off on the DC side. The negative DC is the easiest connection because that literally connects from the negative post of the inverter to the negative bus bar on your battery system. Now the positive terminal on the inverter is going to go to an inline fuse, and then the inline fuse is going to go to the positive bus bar on your battery system. Victron recommends a 400 amp fuse. I actually only had a 300 amp fuse, so that's what I used, but I will be installing a 400 in place of that. Now on the AC side, I think this gets a little bit more confusing for people. I know I was confused at first, but once you get the hang of it, it is quite simple. So think of the AC in as the power that's coming from your shore power, your generator, or if you have a transfer switch. In my case, my AC in is going to go to my surge protector, and then the surge protector goes to the AC shore power plug. Now the AC outside is what's going to go back and actually power the entire coach. So that's going to go AC out from the inverter back to my 30 amp AC breaker. That's going to give 30 amps of power to the entire AC breaker panel, which then runs all of the appliances that are connected to that, including all the outlets, the air conditioner, the microwave, the water heater, all of it. Now I think the hardest part for most people might be running the AC wires. I know it was for me, and actually took me about 2 days to actually find the route. And the route I ended up taking was through the front of my coach. There is an electrical access panel, which leads to most of the electrical wiring and a hole underneath the bed where I can get the wires up in through, which then went through the pass-through to the inverter. Now to get back to my AC breaker panel, which was on the other side of the coach underneath my refrigerator, I ended up removing all the self-tapping screws on the Corioplast on the passenger side, giving me just enough access to feed the wire through the framing of the RV. The front 2/3 of it was fairly simple, but once I got towards the back, the gray tank was in the way, as well as the propane tubing, which hindered access underneath the Corioplast. I only had to cut one small access hole in the Corioplast, where I was then able to drill a hole underneath the refrigerator through the floor, which allowed the AC wires to go up and through. Now let's get into the rest of the installation. Okay, the first thing we're going to talk about is actually mounting this inverter, and I chose to put it through the pass-through of our RV. Some people like to put them inside where their batteries are or under the bed, but if you saw our battery installation video, we do not have room for the inverter at all in there, so that's why it went through the pass-through. Now Victron does recommend mounting this in the vertical position for maximizing cooling and airflow. You can mount it in the horizontal position, and I've actually seen dozens of people do it, but I figure if I have the space and the room and they recommend that that's the way to do it, I'm definitely going to do it for the optimal cooling effect. You can see the wall of our pass-through here has a very thin piece of wood with the gray felt on it. If you look behind it, you can actually see the framing where it's screwed into the wall and also stapled together. So that's where I chose to put my mounting board, which is a 1x12 piece of pine, and I just screwed it right into the studs so that it had a nice firm mounting location. Actually, mounting the Victron inverter is fairly easy. It comes with directions on how to do it, as well as this mounting cleat that you basically screw into the wall, and then you'll hang your inverter on that and then screw in a few more additional screws for the extra support. These inverters do weigh about 60 pounds, so they are fairly heavy. And honestly, it took me way longer to figure out where to mount it than it actually did to mount it. Next, I need to figure out where I was going to route my wires through the pass-through wall. So I used a small 1/8 inch drill bit just to run little pilot holes through to kind of give me an idea on where I wanted to actually put my larger 1.5 inch hole with the hole saw. This is always the scary part too, when you start actually drilling holes or cutting things. This is a brand new RV, so it definitely took me a little bit to build up the courage to puncture through that first hole, but measure twice, cut once, they say, right? Once the inverter was mounted and I now have a clear hole to where I'm going to run my wires, I needed to get the cabling ready, which I started out with the DC side. So as I mentioned in the previous video, we are using 4/0 battery cable, and I do have the tools to make my own cables, which is from Temco. It's a crimper as well as a cutter, as well as nice copper tinned lugs. Someone asked from the first video if I thought making your own battery cables, purchasing the tools for it, was worth it if you're just doing a single install. And I think if you're doing the inverter as well, where you don't know how long your runs are going to be, it definitely, I think, can make sense to purchase it. It's really not that hard to make battery cables. There's lots of tutorials on YouTube. If you were just replacing your batteries, you might be able to get away with buying 1 foot or 2 foot leads. But for example, here we had to use 5 feet of the 4/0 cable to connect the DC side of this inverter. Don't forget about your heat shrink, and I talked about the heat shrink gun here before. This little guy definitely makes the job clean and easy. After making the DC battery cables, I moved on to the AC side of things, which brings me to the circuit breaker panel as well as the converter that came with our coach. Here you can see it's actually all one unit: the AC breakers, the DC fuses, as well as the 65 amp converter on the left side here. Our converter was actually one of the newer ones from Progressive Dynamics, which had the little switch that allows you to switch between lithium and AGM batteries. And basically that will change the charging profile or the voltage that it charges up to. Now with the new inverter charger, you are no longer going to need the original converter. All of your 12 volt is going to run from your batteries, as well as the charging will come from the inverter now. So we actually just went ahead and disconnected the converter from the AC side as well as the DC side. Once I removed our breaker panel from the cabinet below the refrigerator, I really got a good look behind it to see how I'm going to start to run the AC wires all the way back. Now in our coach, the inverter's on the front pass-through, and our breaker panel is below the fridge in the far back, maybe a good 15 plus feet away. Once I removed the panel next to it, I really got a little bit more space to see what's going on behind there. And this is where I actually got pretty frustrated and spent about 2 days trying to find the best way to route these AC wires from the front to the back. I always like to be as innovative as possible, and so I was trying to use the original hole where all the rest of the wires were running through, and I had a good 25-foot fish tape, and I was trying to run that fish tape from the front to the back through the floorboards between the joists just to see if I could run the AC wires that way without worrying about anything on the outside. Well, after looking at multiple locations on how to gain access to this, including underneath the sink as well as underneath the shower, I realized the best spot for me would be underneath the fridge. So after messing around for the 2 days, I did find the best way to route the wires on my particular coach was to go underneath the floor inside the frame of the RV. So the Corioplast on the bottom of our RV was actually held in by dozens of self-tapping screws and washers. Once you actually drop all the screws on the side, the Corioplast just doesn't drop on my RV like you would think it would. There's a lot underneath there that's still holding it up. Our model has propane pipelines that are running along the frame as well, and that actually was holding the Corioplast up. So I could only get it down just enough to get my hand and part of my arm in there to run the wires. As I was dropping my Corioplast as much as I could, I noticed there was some water underneath. It turned out to be just residual water left over from when our dealer did the PDI cleaning of our RV, and they pressure washed it, getting water underneath this part of the RV. And so just a little bit of water was stuck between the radiant foil barrier as well as the Corioplast. So I had to drain that out, which really did sidetrack me in this project. So I apologize, I didn't film as much of the running of the wires as I thought I did as I'm looking at the footage months later. But running the wire, we basically followed our auto leveling wires that were inside that space as well. So it went right through the framing, right through the holes that they already provided right next to it. Actually, running the wires only took me about 45 minutes, and that was probably the easiest part of the job. But again, it took me 2 days to find the perfect route. I did have to drill a hole underneath our refrigerator behind the AC breaker panel to fish the AC wires through. Now, because of that steel pipe where the propane ran through, as well as the gray tank and the black tanks that were right in that same area, I did have to cut a little bit of a flap to be able to fit my hand up through the Corioplast to feed the AC wires through. And then on the battery side, I was able to run the AC wires through the same hole that the auto level wires go through, as well as where all of our 12-volt wiring went through in the battery install. Then with our hole drilled through the pass-through wall, I was able to then put the AC wires through there to meet up with our inverter on the other side of the pass-through wall. I did decide to go with a hardwired surge protector. There's a few options out there. I think the main one is Progressive Dynamics, but I went with the Hughes Autoformer because it has Bluetooth capability, which I absolutely love when I'm putting together my systems, as well as a replaceable surge module if it did get hit by a power spike. Now, this thing is fully automatic and will check for under voltage, over voltage, shut off if it detects it, turn it back on when it's safe, as well as check the wiring at the campground for the usual reverse polarities and miswirings. So for another 250 bucks or so, I felt this was a very easy option to put in, as you're already dealing with the AC wires right there. So the installation of this was the easiest part of the day, and it probably only took about a half an hour to install the surge protector. And basically the surge protector is your first line of defense from the external shore power. So it goes in line from your shore power plug to the inverter. So the power must pass through there first and be deemed safe by that before it actually allows the power to go through to the inverter and the rest of the system. So literally the installation here is just 3 wires on each side, your line, your neutral, and your ground, coming from the AC side. So this orange Romex wire right here is the main AC in. This goes back to the shore plug on the back of the RV, which goes into the power pedestal outside. So we're gonna disconnect that from our main breaker box, which is how most RVs are set up. We're gonna take that AC in and we're gonna put it into our surge protector here, which I'm gonna mount, I believe, right back there. And then we're gonna take our new Marine Romex AC wire, and we're gonna take that from the out of our Watchdog surge protector, and that's gonna go into the Victron Multiplus in the front of the RV. And that's this wire we just ran. So then from there, AC power is gonna flow from the pedestal into this surge protector and then right into the Multiplus. Then we need to run one more of these AC marine wires, which is gonna go from the outside of the Multiplus, and that's gonna go right to where this orange original Romex AC in went, into this breaker panel. That way, as soon as we flip the pedestal power and this thing says it's okay, then it's gonna go to the Multiplus, and then it's gonna come back and power up our AC breaker panel. Now I want to take a quick second to talk about the AC wiring. I used Romex AC wire on my last build, which was the van. And in that installation video, it was probably one of the biggest comments I got from people saying that using Romex in a mobile situation will cause it to burn up. It's highly illegal and against code to use Romex. That's going to start a huge fire. To your insurance company is not going to insure you anymore. And at the time, I had never even heard of flexible marine AC wire, but to me, it didn't make a whole lot of sense because every single RV manufacturer out there uses solid core Romex wire. But it definitely got me thinking about the AC flexible marine wire, and now that I know about it, and it's actually not that much more expensive. I got 100 feet for about $120, whereas I think the Romex was actually quite a bit more expensive. Copper wire has definitely gone up and fluctuates quite a bit in price. But this stuff was great to work with. It was ultra flexible. It's designed for wet environments like marine. And the only thing I didn't have at this time was ferrules and a ferrule crimper to use on the end of these wires, which I wish I would have had. If you haven't seen what wire ferrules are, they're not that common over here, but they are really nice, and I did use them in the next stage of my install on the solar. So I do recommend using this AC marine wire if you can, as well as using ferrules. So now that we have 2 runs of AC wires going from the front to the back, we'll call that AC in and AC out. All we need to do now is make the connections at both ends. On the inverter side, it's extremely simple. Line, neutral, and ground. Again, the ferrules would definitely come in handy while installing these. So you can see on the inverter side here, there is AC in on the left and AC out on the right. So the AC in is coming from our shore power as well as the surge protector. And then on the AC out, we're gonna hook this up on the inverter side. And then on the other side of the AC out, that is what goes to your AC breaker panel. If you watch any of Explorist Life, Nate's videos, and kind of the builds that he does, he's now putting, instead of 10-3, he's doing 6-3, so much larger wire, and he's putting a 50 amp breaker in here to allow the Multiplus to be able to boost above that 30 amps. And that is something I actually thought about before doing this, but I couldn't get the wire in time, and it's actually pretty expensive to get that larger wire. So I ended up ordering kind of different types of wire, and I was always contemplating, am I going to use Romex? Am I going to try this new, it's not new, but new to me, Anchor marine wire? And so we'll still be able to use the Multiplus assist benefit if we're at somebody's house and we put it down to like 15 amps or 20 amps. It can still boost it up into 30 amps with only drawing off of a household breaker. Looking at the AC breaker panel here, you can see our black line will go to the 30 amp power side of the breaker. And then there is the neutral and ground bus bars that the other 2 wires will go to. Now everything else factoring the RV stays the same. All we did was complete power back to the circuit panel here, which will then power the entire coach. Next, the DC cabling, which is usually easier for me than the 110, 120, just because I'm more familiar with it, but negative, positive, big 4-aught battery cables. And then down here is the case ground, which I ordered some 4-aught battery cable for that as well, and it just showed up and it's the wrong size. So it was mispackaged. There's a lot of misinformation and, I don't know, controversy about what size wire to use on that. A lot of inverter manufacturers will recommend anywhere from 10 gauge to 8 gauge to 2 gauge. And just recently, there's code out there that is talking about using the same size cable or one size smaller than your standard DC cables that you use to hook it up. So that's the new ABYC code. This is always the scary part after all these days of work. I'm gonna flip the switch, and before I did that, I made sure to go back and I checked every single connection for tightness and just followed positive to positive, negative to negative, all the DC stuff. And then on the AC stuff, I just did the same thing, line, neutral, ground, following it from point A to point B, just to make sure that it's all good. Got the main connect. Lights come on, that's always a good sign. Now we got to go outside and check out the inverter, and I probably got to switch that on. No lights, but I think that's because it's off. I should have hooked up the Bluetooth dongle, but I didn't. Green light. No smoke. There's that familiar buzz of the Multiplus that I used to hear in the van all the time because it was right by my head. I think I'm going to hook up that Bluetooth quick so that I have the dongle. So this is the Victron VE Bus Smart Dongle, and this I'm going to use for my inverter. And basically what this does is it gives Bluetooth access to your inverter. Limited usage, but you can turn it on and off and also kind of change the current limiter. And this is what I had in the van. I absolutely loved it. I didn't feel the need to have an on-off switch on the inside or the color screen display. I'm totally fine with just having the phone. So this is all it is. It's pretty simple. It has a little power, positive, negative lead. And then it does need to connect to your inverter via the RJ45 cable. You don't have to use these Victron cables. You can use just an RJ45. We're gonna go ahead and use these, get this thing installed, and get some Bluetooth going. All right, that only took about 5 minutes. So here's the dongle. I don't have it mounted yet. I think it's got a sticky pad on the back that you can put onto the side of the battery and it can read the temperature. But this app is really cool. Here's just the switch to turn it on and off. So the batteries are charging up using about 1400 watts coming in. I'm gonna go ahead and flip the breaker to the power coming in and see what happens. There's the beep of the microwave. Switch our fridge. Back to electric. That jumped up, I think, almost 300 watts, 290 maybe. I'm really curious to see how much energy this fridge takes. Voltage coming in 118, 16 amps, and then going out to run the coach is 350 watts. That's everything that's running off a 110. So, success. The inverter we chose for this project is the Victron Multiplus 3000 inverter charger, and we do have the 12 volt model, which has a 120 amp charging capability for the batteries. Now you might think the 3000 stands for 3000 watts, but it is actually a 2400 watt inverter, and the 3000 stands for voltage amps, I believe. There is a difference between the two, so if you want to find out more about that, just Google the difference and you'll learn a little bit about it. Everybody kind of just calls this a 3000 watt inverter, but technically it is a 2400 watt. Victron is a company out of the Netherlands, and they just seem to make really high quality products that the professional installers love to use. There are some pretty cool features on this inverter, and one of the main things is that it does have a power assist capability, which basically means it can boost power in addition to what's coming from your shore power or your generator, as well as being able to limit the actual power coming from your source. So a good example of this is, let's say that you're at somebody's house and you're plugging into a 15 amp circuit. You can then turn down the limiter to that 15 amps so that your inverter doesn't draw more, let's say if you were gonna put on the air conditioner. And so that boosting capability will take the extra power it needs from the batteries while only taking the 15 amps from the house. In addition, this inverter charger has a 4-stage battery charger, which means it has the bulk, absorption, and float stage, but it also has this long-term float stage for people that stay in RV parks or that are hooked up to power for a long time, so that it really does protect and maintain your batteries. This is actually the second one that we've had, and we really do love this brand, and at a price of under $1,300, I think these are fairly reasonable.